You may recall in the previous video we used potassium ferrocyanide and sodium metal to create the mixed alkali cyanide salt. Today we're going to have another go at preparing cyanide salts, only this time in a slightly different and more OTC way. Before we get started, the usual warning. Don't mess around with cyanide salts because they will easily harm or even kill you very rapidly if you ingest them. They are however very useful for lots of organic chemistry, and we've featured them in many previous videos. Let's do it. Here's our first reactant. As before, we're using potassium ferrocyanide as our source of cyanide ions, and here's 8 grams of anhydrous salt. If you have crystals of the dihydrate, you can heat these in an oven at 150 degrees C for a few hours and stir them around occasionally to get the fine pale yellow anhydrous powder. Note that in ferrocyanides the cyanide ions are bound very tightly to the central iron atom, forming the ferrocyanide complex. This strong binding makes them relatively non-toxic. Okay, now for our second reactant. Instead of sodium metal, in this preparation we're going to use an alkali carbonate salt. In this case 3 grams of anhydrous potassium carbonate, which is a stoichiometric amount compared to the ferrocyanide. The first thing we're going to do is mix these two dry powdered reactants together very well. And here we are, well mixed together and any lumps broken up carefully. We're doing the reaction on a small scale, so for the heating part we're just going to use this small porcelain crucible. It's important that you've got the lid because we'll want to keep air out during the heating. Too much air and the oxygen will oxidize our hot cyanide salt into cyanate as it's produced. So let's get our reaction mixture into the dry crucible. Here we go. Now we'll use the spatula and pack it down so that it's nice and compact. This will allow better heat transfer. Let's put the lid on the crucible. And now it's rock and roll time. We're going to heat the mixture on our regular kitchen burner. Don't worry, it's our spare kitchen, so there's no food around here apart from the occasional lab chocolate cake. The reaction needs to get pretty hot, so we're hoping that we've got enough heat here to make this work. On the kitchen burner this might take a little while. About 4 minutes of heating. Let's have a quick look. Not a lot of difference. Some brown color appearing around the sides. We'll keep going. While it's heating, let's have a quick look at what's happening here. Here's the overall reaction. It's a little unusual. The effect of the heat causes the ferrocyanide to decompose. In the presence of potassium carbonate we get the reaction producing carbon dioxide, potassium cyanide, and a small amount of potassium cyanate. The iron from the ferrocyanide ends up as iron metal. Note that the iron has effectively been reduced. About 10 minutes in now, so let's have a peek again. We've got the black color starting to form. This is the reaction starting. We're going to leave this for 10 minutes now and then we'll come back and have a look again. Let's fast forward. This is 20 minutes into heating. The reaction is continuing. We've got to keep heating now until the mixture actually melts. Okay, another 10 minutes. 30 minutes of heating in total now. The mixture is completely black, but no sign of melting yet. at least at the surface. So another 15 minutes of heating, 45 minutes in total. And we've now got a melt forming in the crucible. The bottom is red hot and glowing. Looking pretty good, so we'll stop here. Pure potassium cyanide melts at over 630 degrees C. The cyanate at only 315 degrees. So the mixture is bound to melt somewhere in between, and our crucible temperature isn't unrealistic. We've covered the crucible up again and we'll let it cool right down to room temperature. Here's the crucible and contents after cooling. You can see a rusty brown color in there where some of the iron has oxidized. First thing we're going to do now is add just a little bit of water, around 10 ml, and try to break up the solids. After a few minutes of gently scraping, the cake of solid comes loose in the crucible. So now we transfer into a small beaker. And we're going to add a little hot water and stir well until all the lumps have dissolved, leaving only the fine black precipitate. We're there now with all the large lumps dissolved. The total volume now is around 20 ml. We're now going to filter off the black solids and leave a solution remaining with our product in. To do this we're going to use some old school filter technology because we're only dealing with a small amount of liquid. We're pretty much there now. Here's our filtrate. It's only a very pale yellow color, which is great because it means that the ferrocyanide has all reacted. And it's got that characteristic musty weird aroma that solutions of alkali cyanide salts have. Only subtly like almonds, but remember that not everyone can smell that particular infamous characteristic. Well, this probably also has potassium carbonate and potassium cyanate in it as well. But it's a pretty saturated solution, so we're going to first chill it down and see if we can get any solid to crystallize out. In the previous video we used ethanol to precipitate the cyanide salt, but in this case this process will also precipitate the cyanate as well. While that's chilling down in the freezer, here's some water in a beaker. We'll add a little of the back precipitate that we recovered from the filtering process and stir it around. Here we go. Okay, let's use a magnetic stir bar and see if we can demonstrate that it's actually finely powdered iron that has been produced. Definitely a magnetic response, as you can see. Back to our filtrate chilling down. After about 30 minutes we've definitely got some fine crystals forming in the bottom. So we'll keep chilling a bit longer and see if we get any more. And here we go after another 30 minutes in the freezer. Definitely some crystals in there. Let's filter these off, this time using a vacuum, and see what we've got. Here we go. About 1.3 grams of very pale yellow clumpy crystalline solid. Cyanide salts are very water-soluble, so this is actually not bad at all. The cyanate and carbonate are much more water-soluble at this temperature, so we think there's a good chance that this contains a high proportion of potassium cyanide. It definitely gives all the right chemical reactions in some tests which we'll come on to in a moment. As far as yield goes, if it's pure cyanide salt then that's an 18% recovery. But most of the product is still in the liquid filtrate along with other inorganic salts as well. Well, this process seems to work quite well, and it's definitely a lot more OTC than using sodium metal. But how good is the product? So let's look at some qualitative tests for cyanide. To do this we'll use the aqueous filtrate, which in theory contains most of the product. The first test you've seen before because we did it in the previous cyanide video. Let's add some saturated copper sulfate solution to the filtrate. Dark-colored copper to cyanide is produced which rapidly decomposes forming cyanogen gas. There's also a green color, so this shows there's definitely some carbonate remaining in the filtrate as well. Okay, so that's one test. But let's do this again now with a slight variation. Here's our copper sulfate solution again. Now we'll add some sodium hydrogen sulfite. This will form a yellow-green colored complex in solution with the copper. Here we go. And now we'll add the filtrate containing our suspected potassium cyanide to this, and see what happens this time. This time we've mostly got a white precipitate forming. This is copper-1 cyanide being formed as an insoluble precipitate. There's a slight brown color due to some copper to cyanide forming transiently before it decomposes. Copper-1 cyanide is very interesting because it is a useful reagent in organic chemistry. We may be preparing and using it again in a future video. Well, so far that series of reactions and color changes is definitely consistent with there being alkali cyanide present in the solution. Let's try the classic test next. Here's a bit more of the filtrate. And here's an aqueous solution containing the mixture of iron 3 chloride and iron 2 sulfate. Interesting. At first there's a dense green precipitate of what looks like iron carbonates. But the second there's an excess of iron salts, a deep intense blue color appears. This is the famous Russian blue, a complex molecule comprising iron and cyanide ions. Well, no doubt, there's some potassium carbonate in the mixture, but there's also a lot of cyanide as well, as you can see from the intense coloration. So this method is a success. We still don't know exactly how much cyanide it produces and how pure our crystalline product is, but it's giving qualitative tests. We'll have to come up with a quantitative way to measure this, possibly by making copper-1 cyanide and then weighing it. Please stay safe with cyanide, and stay tuned for more reactions.